Okay, so we're going to do the second part of 6.7. It's composition of inverse functions. So this first part, I'm going to do an example kind of showing what this whole thing means. The last book that I taught out of, you actually had to show this. This book didn't really do it that way, but I want you to see that it does work. If things are inverses of each other, if you put one function into the inverse and then the inverse into the function, you should get x both times. Okay, so I'm going to do one of those. I'm going to just do it way at the end. So I'm going to put C and for example. Okay. Okay, so that's what we're going to show. One of my equations that I'm going to use is in one of the got it questions. We're going to have to do this anyway, so I'm going to use this one. Y equals 2x plus 8. Okay, so just for review, we're going to find out what the inverse is, and then we're going to show this property right here. So yesterday we learned how to figure out what the inverse was, and what we do is we look at the beginning. If it's written in function form, we replace that function with a y, so it looks like a slope-intercept equation, and then we switch the two. So the y becomes the x, and the x becomes the y, and then we resolve it for y. So I'm going to subtract 8 from both sides, and then I'm going to divide by 2. Okay, so also, I think I'm going to run out of room here. You need to put it back into function form, which means the inverse is 1/2 x minus 4. Don't write it as the function if you're finding what the inverse is. Make sure you put that -1 in there. So how do you show this property that we just did? One of the functions is 2x plus 8. The inverse is 1/2 x minus 4. Basically, to get that, I divided both of those things by 2 and listed them separately. So what we're going to do on the first one is we're going to plug the inverse into the function. Okay, so we're going to do this one first. So here's my inverse. And it says we're going to plug the inverse into the function. Okay, so that means wherever there's an x, I'm going to put in a 1/2 x minus 4. Okay, so it looks like this. 2, I think my pen is not going to survive much longer. 2 times 1/2 x minus 4 plus 8. So I'm plugging it into this one. Simplifying a little bit. Okay, so when you use the distributive property, you get 2 times 1/2, you get 1. 2 times -4, you get -8, and then plus 8. And then at the end, you get x. So if you actually had to show this, you do have to show these parts, even how, regardless of how minor you think they are, and you should get x at the end, which we did. Now the next part you're going to do, you're going to plug in the function into the inverse. So with this one, we're going to plug the function into the inverse. So that means in the inverse, anywhere there's an x, I'm going to put a 2x plus 8. So 1/2 times 2x plus 8 minus 4. 1/2 times 2 would be x. 1/2 times 8 would be plus 4. And then you subtract 4 from it. Oops. And you get x. So notice how these two both give you x, and that basically tells you that since they're x, they are inverses of each other. Okay, so if you had to actually show that, that's what you would have to demonstrate, is how do you get x for both of those? Show all the steps, simplify it, and you should get x for both of them. Another part of yesterday, we'll just back up just a little bit, was how do you graph inverses? How do you know if they're inverses of each other? So this is one of the got it questions. I'm kind of jumping around a little bit. Okay, let's go to this first one. What is the inverse of 0, negative 5? Flip them over. So you'd go through the same thing on every single ordered pair and just flip them over. Okay, doesn't say to graph them, doesn't say to do anything else. You're just finding out what the inverse of all of those are. This one we just found out. See end, y equals, let's go like this instead. One half x minus 4. Okay, then it says what's the graph of both of those? Didn't put my graph paper in here, but I guess I'll take it. Okay, so this one crosses at 8. And then the slope says up 2, right 1. So I'm going to go down 2, left 1. And draw it in. Now, do you guys remember what the line is that you go over when you're trying to find inverses? That dotted line that we did yesterday? Y equals x, or 0, 0, 1, 1, 2, 2, 3, 3. It's basically the diagonal of the graph. So I'm going to put those in here. And basically what the inverse means is if you reflect what you have over that line, it will look the same on the other side if you just fold it right in half. So one of the ways that you could do it, and it's not going to be very easy to see on this one, is, for instance, if you look at this one and it's like 2 diagonals away, you're going to do 2 more diagonals on the other side. Some of them are really easy to see, some of them are not. So what was the other way that we used if we weren't really sure? We'd go back to the ordered pairs again. It would be really easy to find a few ordered pairs here, right? So just do that. So you're going to basically name them. So let's say we go to this one right here. That would be negative 3, 2. And if you need to write it, write it. If you switch it around, it would become 2, negative 3. So we'd go over here and we put that point in. Okay, I'm going to change colors though. Okay, so there's my first one. This one is 1, 2, 3, 4, negative 4, 0. If you switch it, it would be 0, negative 4. And you could do it in your head, you could write them down, you could do whatever you need to do. Now, when I look at this one, once you get a few, could you not figure out the slope of it and just count? Yeah, because this one I kept going down 2, left 1, down 2, left 1, down 2, left 1. This one, if I do another point, I'll be able to tell what that slope is. So let's do negative 2, 1, 2, 3, 4. Negative 2, 4 becomes 4, negative 2. And of course that would be up 1, right 2. Instead of down 2, left 1, it's up 1, right 2. And you could draw it in like that as well. So super, super easy. Don't let the actual picture freak you out. Find some ordered pairs, make it look the same. This one's not so bad. It's the ones that kind of overlap each other, like spin around it. those are a little harder, so I recommend doing ordered pairs when you get to those. Let's go back to this one. Okay, so just looking at composition of functions. Before you do some of these, you should be thinking, what numbers can I plug in here? What numbers, can I get for answers? So with this one, is there a restriction when you have an x minus 1 on the bottom? Yes, x can't equal 1. So let's keep that in mind. So the domain of this one, all reals except x cannot equal 1. So keep that in mind. So if we find the inverse of this one, the first thing we do is replace f of x with y. And then we switch those variables around. So x equals 1 over y minus 1. Then if I put a 1 under the x, it kind of looks like I could cross multiply this one. So it's x times parenthesis y minus 1 equals 1. And then you could distribute the x, but I'm not going to. I'm going to divide it right away because then I can get rid of it and I wouldn't have to do that distributive property. So then I have y minus 1 equals 1 divided by x. And the last thing I need to do is add 1 to both sides. And then I turn it back into function notation. And that is it. Now, if you're actually just finding the inverse and it doesn't say to find the domain, you really don't have to. Where the domain comes in is if you are plugging in numbers like the next two, and this one's supposed to be a 1, then it kind of matters what numbers you're plugging in, because maybe you're plugging in numbers that you shouldn't even be plugging in. Okay, so with the next one, it says we want to plug the inverse into the function because the inverse is on the right. Okay, so we're going to plug a 1 into the inverse, and then we're going to see what happens. Okay, so we're going to find f of, if I plug a 1 in there, I get 1 divided by 1 plus 1, right? Let's go like this instead. I'm going to write it a little different. Let's find the inverse of 1. So I'm looking down here. 1 divided by 1 plus 1, that would be 2. And then I take that answer, and where do I plug it into? Because all I've really found is this part, right? I need to plug that answer into the function. Okay, so I'm taking this, and I need to plug in and find out what f of 2 is. So I go back up to the beginning, and it says 1 over 2 minus 1, which is 1 over 1, and you get 1. Now, is 1 in the domain of the inverse? Would it be in the domain of this one? It would, right? The only number you can't have here would be 0, because you can't divide by 0. So it worked because we could plug in the domain of that function. So we're okay on that one. Let's look at the next one. Here we want to look at what is f of 1 first, and then we're going to plug in that answer into the inverse. So what was my function again? 1 divided by 1 minus 1. Can we do that? No, we can't have negative numbers. If you had to explain why, though, is 1 in the domain of the function? Remember when we set up here, we could have everything except for 1, and we were trying to plug 1 in there. That's why it doesn't work, is because 1 isn't in its domain. So 1 isn't in the domain of f. Okay, now let's look at that other one just one more time. Is 1 in the domain of the inverse? Yeah, we can do 1 there, right? We just can't do 1 in this one, so it depends on which one you're plugging it into first. Okay, so if you had to explain, at least you have something to go by there. If you actually got a number, it wouldn't matter because that number is probably in the domain. Okay, let's do some domain and ranges just to kind of review a little bit. What would the graph of this one be? 6 minus 4x. Would it be a line? Would it be a parabola? Would it be something different? What do you think? Line. Does it matter what numbers you plug into lines? Nope. So anything that looks linear, you're going to have all real numbers for both. Okay, because it doesn't really matter. If you put all real numbers into the domain, you'd get all real numbers out, right? We could do fractions, decimals, positives, negatives. It wouldn't really matter. Now, in this one, what's the inverse of g? You'd go y equals 6 minus 4x. You'd exchange them and resolve it for y. X minus 6 equals negative 4y, and y equals negative 1/4 x plus 3 over 2. Okay, and I reduce those separately, so I put a negative 4 under each one of them, and I reduced a little bit. Is there a restriction on the domain and range of the inverse then? Nope. The only restrictions you really have are those that have x on the bottom or square roots of things, cube roots, square roots, whatever. So if it's a regular thing like x or x squared, then it does not matter. You'd have all reals. So we're going to do all reals for both of these. And it's because it's a line, and we can graph anything there. Are lines functions? Are all lines functions? What about a vertical line like this? That would be the only one that isn't, right? So if it has any slope to it whatsoever, which this one does, then this would be a function. Okay, so you could put, yes, all sloping lines, wow, are functions. Okay, would there be a restriction on this one for the domain? Did we do this one already? We didn't, I don't think. Okay. What's the restriction on this one? X can't equal negative 2. So you'd go x plus 2 equals 0. X would equal negative 2. That's the only one that gives you 0. So your domain this time, all reals, but x cannot equal negative 2. Okay, then we find out what our inverse is. Y equals 4 over x plus 2. We switch them. We multiply both sides by y plus 2. And then we divide by x, because I want to get it out of there. And then we subtract 2. 4 divided by x minus 2. Okay, that one is solved. And then I need notation. So the inverse is 4 divided by x minus 2. Would there be a restriction on that one? The 4 divided by x part, what number can you not have? That would be negative 4. We can have that. What number can you not have on the bottom? 0. So basically it's everything except for 0. X cannot equal 0. And you can start plugging numbers in. So what if you don't really know? If you plugged a 1 in there, you'd get 4 minus 2. If you plugged in a 2 in there, you'd get 2 minus 2. Anything that gives you an answer works. Anything that doesn't give you an answer doesn't work. So when you go to the left, if you plug 0 in there, you're going to put that on your calculator maybe, and you're going to get an error. Anything that gives you that error, that's the numbers that you don't want. Now, let's do one more composition. And this one we're going to do the inverse into the function. So we're going to do the right part first. You always do the right side first. So we're going to find out what is the inverse of 0. Okay, so we have putting this in here. Can we do that? No, we cannot, because this doesn't exist. And it's because we are trying to plug 0 in there, but we already just said that 0 can't be in there. 0 isn't in the domain of the inverse. Okay, so be careful there. If you get something that doesn't work, ask yourself, is that right? Should that work? Should it not work? If you go back up to the beginning and you actually find the domain and range if it's not asked for, that might answer your questions.